Hello.
Yes, yes, I'm there.
I can see the screen, sir.
You can't see the screen?
Yes, sir. Okay, now I can see, sir.
Okay, you will see, no problem. Now you can see
Yes, sir. Yes, sir.
what you are seeing now?
Sir, sir, in B, sir, the height
Sir, we are
is
seeing a
greater than.
man throwing a ball.
Yeah, yeah, that one, right? I'm
Yes,
checking that
sir.
you are seeing the correct thing or not.
Yes, sir.
Okay, there are so many files. The correct file came or not? We have to check. Yeah. So now explain.
Sir,
Explain, please.
in B the height is greater than A, C, and D, and as the height is greater, so the gravitational potential energy is higher. So that's why, sir. It's answer B.
So gravitational potential energy related to height, right?
Yes, sir.
Isn't it? And what about others like M, G? Why they are not affecting the gravitational potential energy?
Sir, because the mass of the stone is constant and G is
Yes,
also constant.
yes. So if we are taking another height, then we are getting another gravitational potential energy, right? For the same stone, right?
Yes.
Isn't it?
Yes.
That's why our H is important here for gravitational potential energy if we are using the same object. This is the most important point for you all. Then we are going to 15. Continue.
Yes, sir.
Shivanto, continue.
Yes.
Which one, sir?
15. Continue
Okay, a
15.
piston of area 10 centimeter square is pushed
What?
slowly into a
A
very large.
pressure.
A piston of area 10 centimeter square is
Yeah.
pushed slowly into a very large cylinder containing gas at a pressure of 10 Newton per cent cube. The pressure of the gas
Newton per
10,
centimeter square.
sorry, centimeter square, sorry, sir.
Yeah, yeah.
Okay, the pressure of the gas remains constant as the piston moves a distance of 0.10 meter. What is the
Mhm.
force of the gas on the piston and what is the work done by the piston on the gas?
Okay,
Yes,
so
sir.
how we'll get
Sir,
it?
I haven't understand this one, sir.
Yeah, you haven't understood this one, right?
Yes, sir.
Okay, so who understood among you? I think Kazi understood. Kazi,
Which one, sir? This one?
we are talking about this one.
Yes, sir. Understood.
So you explain so that we can all understand.
Okay, sir. Sir, the first one, it is told that to find the like force. No, sir.
Yes.
Then the formula of force is P is equal to Fa. A piston of area 10 centimeter square. No, sir.
What
Hello.
is the formula?
Yes, sir. The
What is
the
the form?
formula of force is like the power is P is equal to Fa. Then you have to rearrange F is equal to like P. F is equal to Pa.
Yeah, I
And
told
P
you
is for
to
power.
listen. Here, when you are explaining, you explain in a way that you are explaining to someone he did not understand anything. That's why you should go slowly and pause.
Okay, sir.
Step by
Okay,
step
sir.
you go, right?
Okay,
Otherwise,
sir.
they will not understand your explanation. Yeah, continue.
Yes, sir. So, sir, then after we rearrange the formula, we can see the, sir, the pressure, like the power of it is 10 centimeter cube. Yes, sir.
Mm-hmm.
Then the area of the piston is 10 centimeter square.
Mm-hmm.
So we have to simply multiply with 10 multiplied by 10 centimeter square. My centimeter square is gone. Then it will be 100 Newton. The
Okay.
first one is done. Then the work
Nice
done.
one,
Work
nice one.
done is equal to force multiplied by distance. Yes,
Mm-hmm.
sir.
Mm-hmm.
Then it is 10 centimeter square as it is a power of pressure, and then it's 0.10 is the distance. So we simply multiply, then we get 10.
Yes. So it is 10 joules. Now with you, I am adding something more. Like when one student will understand that how we are using this formula or why we'll use this formula. If they identify this from the question, like when you are reading the question, Shimanto,
Yes, sir.
in class also, I told you that when you are reading the question, numerical question, you should mark, right? What is given here? A
Yes, sir.
piston of area 10 centimeters. So you are getting here A, right? Mark it
Yes,
that
sir.
you are getting A. Then you are getting what? Pressure. So it is P, right? Isn't
Yes,
it?
sir. Yes, sir.
And you are getting here distance D. Then
Oh, yes,
formula
sir.
formula will work in your brain. Okay. Then they are asking you force, so you can understand, yes, this force we can find from that formula, P equals F by A, because I have already P and I have already A, so this formula will help me to get F. I think this is helping you a lot, right? The way I'm explaining you.
Yes,
What do you
sir.
think?
Yes, sir. It's helping.
Yes.
Helpful.
So this way the formula will come in your mind, because when you are writing the exams, that time you are dealing with couple of chapters, topics, right? And
Yes,
maybe
sir.
you will get lots of formulas. Then you cannot think easily or quickly that which formula you should apply. If you
Yes, sir.
mark it here, observe it here, then the required formula will come easily in your mind. Am I right?
Yes, sir.
What do you think, Ravi? Does it help? Ravi?
Yes, sir.
Yes.
I think.
So you are asked to find the work done as well. So for work done, you need force and distance. Distance is already there. Force already you
Yes,
found.
sir.
So your answer is coming automatically. Clear now? Now
Yes, sir.
16. 16, Nubrat, read. Hello, Nubrat.
Okay, yeah, 16.
Yeah,
A
please.
student uses a Newton meter to pull an object horizontally along rough ground. The student multiplies the Newton meter reading by the distance moved by the object. What does the calculation give?
Hmm.
The work done
This,
on the object, sir. Too much
Do
easy,
I
sir.
have to read out the options too?
yeah, you can see the options and tell us that why we are choosing D.
I can, sir. I can.
Someone
I can, sir. I
else.
can.
Yeah, Nubrat. Look, they are saying Newton meter. How the clues are given in the question. Newton meter means the meter which measures Newton. Newton is the unit of force, right? Hello, Nubrat.
Yes, yes,
So
yes.
we are measuring the force using this Newton meter. Clear now?
Yes.
And they are saying that distance moved. So the Newton meter is giving you the force, and that is multiplied by the distance. So F into D, right? And you know that F
Yes.
into D is giving you the work done. Here,
Yes.
some students, they are not getting uh, the idea of force here directly, right? So they should be
Yes.
thinking about it or analyzing the question this way. Then next one, I request other
Sir, I can.
students. Farabi, let Farabi
Sir,
try.
sir, there is
Farabi,
some problem in Farabi's mic.
there is some problem. What
Sir,
problem?
Farabi is in Gram. There is no mic. I think.
No, he is in Dhaka now. I know. He told me that he is Dhaka now.
Sir, mic kine na.
Okay, leave it. Now, anyone please from you, can you take the snap and send it our physics group? We will do this better. iPhone, Nubrat's iPhone will do it better. Or Nubrat doesn't have connection with group. So any other, who can take the
Which
snap?
one, sir? The participant.
Yes, participants. Who
Yes, sir.
is
I'm
doing?
sending it. I have taken. I have I've sent it. Send it.
Yes,
I've
please
sent it.
send it please. Now, Rabi, tell me, Rabi, what is the answer? 17. Read the question and tell me the answer.
Okay, sir. A constant force F pulls a block of weight W of the slope down. How much work is done in pulling the block up the slope?
Mhm.
Okay.
So,
Sir, it's like F into L. So,
force into distance moved, right?
yes.
That formula. But when we will use uh, F into H,
Uh, I don't know, sir.
okay, and when we'll do W into L, when
I
we'll
can
Sir,
do,
tell, sir. Sir, I can tell, sir.
Sir,
yeah,
I can tell, sir.
Sir,
yeah,
I can, sir.
yeah, tell me please.
Sir, we can use F into H when an object is falling towards the ground. That is when we can use F into H, and W into D. I don't know, and W into L. I
Only
don't know.
falling.
No, no, no. When it is mentioned and against the gravity.
Yeah, not only falling.
Oh,
You should say something is working against the gravity that time. Okay, we are taking the vertical height. In
Yes,
yesterday's
sir.
class, we discussed it, right? They who missed
yes,
the
sir.
class, please check the recording. There we discussed it. Clear now, everyone?
Yes.
Yes, sir.
Then next, 18. Shimanto.
Yes, sir.
Continue, 18.
A builder carrying 6 bricks climbs a ladder. Each brick weighs 25 Newton, and the builder climbs a vertical distance of 4 meter and in 8 seconds. What is the average power used to raise the bricks? A 13 watt, B 7,000 watt, C 4,800 watt.
So we have here force, distance moved, and time, right?
Yes,
And
sir.
from the formula, P equals work done by time. Ah, so that one you are getting force into distance moved for work done. And time is here 8 seconds. 150 multiplied by 4 divided by 75 watt. Clear now, everyone? This one? A similar
Yes, sir.
question yesterday we did. They who were not present yesterday, now you got the idea that if there is no work done given directly, we can find the work done from force and distance moved, right? And divided by time to get the power. So that's all for today, right? Our class will be
Yes,
over
sir.
in 1 minute. We are
Okay, sir.
closing our class. Thank you so much for joining.
Assalamu alaikum.
See you again tomorrow, right?
Yes, sir.
So tomorrow we will do practical class.
Oh my God.
Sir,
How, sir?
practical?
Yeah,
How, sir?
we don't have any
Now.
theory class, but we will do practical class tomorrow. Okay?
Okay.
How the
Okay.
practical class will be held tomorrow, you will know. Just attend in the class. Thank you.
Okay, sir. Bye bye, sir.